Students, we're going to do a quick review of fraction division one last time. So the basics are, if we start with a fraction like 1/5 and we divide it into three parts, let's think what that would look like. We could split this into three parts, and each one of those parts is going to be super tiny, right? Very tiny. That's what it looks like, a little bit neater. How big is each one of those parts? Well, if I took that 1/5, I'm just going to focus on dividing it into three parts. Each of those parts is actually going to be 1/15th. 1/15th. If you count all those up, there's 15 slices. So we had a fraction, and we ended with a fraction for our quotient. If we start with a whole number, here's three circles here, and if I'm going to divide them into fifths, how many fifths fit into three whole? Well, here's what it might look like if I took those three and broke it into fifths. Each one of these slices is a fifth, so think 5/5 in the first one, and 5 more fifths in the second. How many fifths would we have in three whole? Well, if you count all those up, you would wind up with a total of 15. Notice we ended with a whole number. We started with a whole number. If we break it up into a bunch of tiny little pieces, we're going to have 15 of those tiny little pieces. So if we start with a whole number, we end with a whole number with fraction division. But we don't expect you to actually draw it every single time. You can use the algorithm. The algorithm is simply the mathematical steps that we take each time. So I know I'm starting with a fraction. I'm going to end with a fraction. So think if I have a half and I split it into three parts, well, it's going to look kind of like that, right? Three equal parts. Well, how big is each one of those parts? Is this a third, a fourth, a fifth, sixth, 10th? What is that? Well, if we take a look at the whole piece here, all right, there's my half. You can see it on the right-hand side, and I broke it into three pieces. How many pieces do we have? 1, 2, 3, 4, 5, 6. So each piece is 1/6. Let's see if that works with our algorithm, our steps. How did we get a 6? Well, 2 times 3 gives us 6, and since we started with a fraction, we end with a fraction. Let's check this one out. Is it still going to work when we do 2 times 3, or 3 times 2 is 6? Well, let's see. Here's our three whole. If I'm going to see how many halves fit inside that, each one of these pieces is 1/2. How many do we have? Well, you can see there's 3 of them, 4 of them, 5 of them, 6 of them, and that matches our answer. A half will fit into that 3 exactly 6 times. And we start with a whole number, so we end with a whole number. Easy peasy, right? Let's do a little word problem here. 1/4 pie is split among 3 people. Which of these models shows how much each person will receive? Well, what can we eliminate right away? We have 1/4 of a pie to start out, and we're going to divide that into 3 parts, right? There's our math problem, 1/4 divided by 3. Well, you're not going to get 1/3 of a pie. That's more than we started with. Can B stay an answer? No, that's what we started with. We want to take that fourth and break it into 3 smaller pieces. So let's see, is it going to be C or D? Well, using our algorithm, I know 4 times 3 is what? It's 12, and we started with a fraction, so we're going to end with a fraction, 1/12. Which picture, C or D, shows 1/12? Take a look at it. Well, if you actually look at choice D, there's the 1/4 that we started with. We broke it into 3 pieces, so this little sliver right there is 1/12, and that matches our algorithm answer too. What if we start with a whole number? We have 6 pounds of clay here. We're going to divide it into portions that are each 1/4 pound. So let's take a look. Which model would show 6 divided into fourths, A or B? Which shows 6 wholes divided into fourths? Well, A shows that each one of these pieces is a sixth, so it's not going to be A. B is the one that we're going to focus in on. B is the one we're going to focus in on because there's 6 whole, and you can see they're broken into fourths. So you could count all those fourths, but it's going to take us a while. We could just use our algorithm and say, if there's 4 fourths in each one, what is 4 times 6? And since we started with a whole number, we'll end with a whole number. And how many portions? Well, it's going to be 24 portions. And then back to one more modeling with fractions. 1/3 of a pan of brownies is split among 3 people. So there's our problem, 1/3 divided by 3. Which model shows the amount each person will receive? Well, they're not going to get half a pan of brownies. We didn't even have half to start with. What about C? Is each person going to get 1/3? Well, no. That's what we started with. We need 1/3 broken into 3 parts. So we can think about multiplication. 3 times 3 is 9. Should it be 9 or 1/9? Well, we started with a fraction, so we're going to end with a fraction of 1/9. Which model shows 1/9? ninth, 1 part out of 9? A or B? Well, it's going to be A. This is 1/9. You could count. There's 9 slivers there, and there's 1 piece out of 9. So that's the portion they'll receive. All right, one last topic, and then we're all done. We can connect fractions and division. Division sign actually looks a lot like a fraction, doesn't it, with our fraction bar there? So let's check this out. 4 brothers are going to share 3 sandwiches. These squares down here represent the sandwiches. These 3 guys are going to share. What fraction of a sandwich does each brother get? So we have 3 sandwiches. Well, you could actually break them all into fourths and say, okay, brother number 1, you're going to get a fourth from this and a fourth from that and a fourth from this. And brother 2, there's your fourth. And brother 3, fourth. So how much is each brother getting? Well, each brother is getting 3/4. So take a look how that connects to the division problem of 3 sandwiches, right, divided among 4 brothers. 3 divided by 4, that is 3/4. Because our fraction bar means division. And our division means a fraction bar. It's all connected. 3 divided by 4, 3/4. So check out this one, our last one here. Relating fractions and division. This time we have 40 pounds of rice. That's going to be divided into 6 bags. So there's our problem, 40 divided by 6. 40 divided by 6. So think what that would look like as a fraction. Well, the number we're dividing goes on top, and our divisor we're dividing by goes on the bottom. So 46. Okay, but what's 46? Like, what is that? 0, 1, 2, 3? Is it between one of these numbers? Well, since this fraction bar means division, we can simply write a quick division problem. We can say 40 divided by 6. Well, 6 doesn't go into 4, but it goes into 40. 6 times what is close to 40? 6 times 6, right, is 36. And we wind up with 4 leftovers. 4 what? Well, 4 6, or we could simplify that to 6 and 2/3. So where does it go in our number line down here? Well, it's more than 6, it's less than 7. So we'll say, oh, it's going to go somewhere in here, somewhere there, because it's more than 6, but it's less than 7. Okay, so our last slide. How can we write these division problems as fractions? Well, 3 divided by 4 is 3/4. 9 divided by 4 is 9/4. So what's 12 divided by 4? What fraction would that be? If you said 12/4, you're right. How about the other way? How do we write these fractions as division problems? 8/3, the fraction, is 8 divided by 3. 3/8, the fraction, is 3 divided by 8. And how about 1/3, the fraction? How could you write that as a division problem? Well, it's 1 divided by 3. So quick review, go back and watch it again if you want to. You guys know how to do this, and you're going to do great on this year's test. Guarantee it.